Hello guys, welcome to another episode of Xa Talk Show. Today's topic is random. We haven't been doing this for a while, for a month I think, and I haven't been doing a lot Xa Talk Show in the past 4 months or so. Like the reason is, there's not much of a reason, but the reason is kind of every time. In the past year, I have been trying to be more focused. So each video is focused on Emacs or Emacs list programming or Wolfram language. So I try to be more focused. So there is less of random chat like I used to do. Like 2 years ago, I used to do almost every day, whatever for 1 hour, whatever comes to mind. So but the more I try to be focused, the less impetus, the less kind of, because you have to plan, you have to think about a topic. It's basically more work. But if I do not have a topic, if I do not have a plan, if I just go live and do talk show, Xa talk show, like the title is supposed to be, then typically I have a lot of topics, like you guys ask questions, I talk. Let's check my video is going, my audio is going good to go, okay? So today's topic is mostly random. Well, I'm gonna talk about Wolfram language. I'm gonna show you Wolfram language and machine learning, okay, neural networks. So I've been doing a lot of that, okay? So that's, and random, okay? So you ask questions, I answer. Okay, pay me, okay? So go to PayPal, you know where to go on my website, xali.info. There's a lot. You go to my homepage, you'll find the PayPal link. So pay me and then ask me questions. I'll answer that question. Okay, or you can use Super Chat. Super Chat, YouTube takes like 40%, they suck your blood. And not just that, if they just do that, that's fine. But they huge censorship and all that. So anyway, today, so my keyboard, as you know, Glove 80. Search for Xali Glove 80. You'll find it. My favorite keyboard now, and this is Ultimate Hacking Keyboard version 2. I have video reviews for them both, okay, on my website. Now let's switch to my screen so you can see. So let's start to do some coding, okay? Again, post questions, say hi, okay, if you are watching. Okay, so let's see. So the first stop, let's do a Wolfram language. This has been one of the things I've been telling the industrial programmers, especially the Lisp coders, for 20 years. Usually they don't listen. So let me demonstrate one of the supremely powerful Wolfram language design, okay? So one of the functions. So let me show you where. And yesterday, so Xa Discord, yeah. So before we do that, let me tell you about Xa Discord. Xa Discord. So I have a Discord channel, and the Discord, they removed permanent links. So right now we don't have a permanent links, okay? But here is a permanent link. Let me copy that. And let's see if I can paste it. Can you guys see the link? That's a permanent link. Well, that links last for 1 week. Okay, we are trying to fix that. So Xa Discord, I write a lot, a ton on Xa Discord on all sort of things. Okay, so that's the Xa Discord. Let me show you the Wolfram language. So if you don't know yet, so you just search for Xali Wolfram language. Hello, Ben. Thank you for the money. I'm doing good. Thank you. Any questions? Post a question and I'll answer. So I've been coding. I'm back alive with Wolfram language. Fantastic. Let me show you. Well, I showed this many times. So anyway, you just go to Xa Wolfram language tutorial. You can download it for free. I highly recommend it. They sponsor me, okay? So they sponsor me. I've been coding Wolfram language since 1992. Okay, so for 30 years, it's kind of 30 years. Not, there's some 10 years I haven't, some 15 years I haven't been coding it. But anyway, I'm back on it now, version 13. So let me show you complan. Okay, so this Wolfram language. Actually, let me start it so you can see. So this is Wolfram language logo over the years. The one, so 1991, this is the one I'm familiar with most. 1991 I've been using. So over the years, and this logo is actually my favorite logo. Okay, so but today, Wolfram language version 13, it looks like that. It came out about 2 years ago, and that's what I have. So actually, so let's start Wolfram language. Okay, this is Wolfram language 12. Okay, not this one. Where is my, okay, so it's actually here. There it is. Oh, shit. Okay, we didn't see the beautiful beautiful logo. I want to show the beautiful logo. Let's try it again. There it is, Wolfram 13. So let's start a new notebook. Let's say 3 plus 4. Shift enter to evaluate it, and let's magnify. Okay, so you can see. I'm going to show you. So Wolfram language, my favorite language. So you can, go to my website and start Wolfram language tutorial. If you are a student, if you don't have a job right now, I highly recommend you download the Wolfram engine. That's for free. Okay, so you can read about it. What's the difference? Wolfram engine, Wolfram script, Mathematica. What's the differences? And so you can download it for free. If you have a job, you work at Google, Amazon, or whatever, or even a small company, I recommend you just buy it. Okay, it's because it's hugely powerful. It's good for life. There's no other language comparable. Okay, so for example, if you want to learn about any kind of science, engineering, chemistry, physics, mathematics, or cellular automata, or computer science, or sort of algorithms you want to explore, or graph theory, discrete mathematics, statistics, probability, they have and especially also machine learning and neural networks. I've been learning a lot of that. I'm going to talk about it today. So it's like nothing comes close. The closest you might have today is, you might get, NumPy, Python, NumPy, SciPy, Anaconda or something. You get the huge 1 gigabyte download of Python. And that's only, I would say, that's only at most 5% of Wolfram language, Mathematica. Okay, that's only 5%. So let me show you one of the function that's in Wolfram language that you will not see anywhere in any programming language like Java, C, C++, Lisp, doesn't matter what Lisp, Clojure, Scheme, Emacs Lisp, you will not see it anywhere. Python, JavaScript, Ruby, Golang, Rust, the power, okay, the kind of the power of Wolfram language. And usually when I talk to this is one of my pain for the past 20 years. When I talk to the industrial programmers, they don't understand. They don't get what you're saying. I talked about this a lot of times in my live stream. Like yesterday, I was talking, there's our friend Hot Dog, in our forum. I explained to him this function, and he kind of get it, but he's like, oh, nobody need it. It's just niche. Incredible. This because you know, so why is that? Because actually, let me show you, because then you don't know what I'm talking about, okay? So as you know, in most languages, you have a map function. So let me show you, okay? So actually, let me start a, let's start a Wolfram language. Let's go to talk show, and today's talk show, and let's start a Wolfram language, okay? So I have written XA Wolfram mod. It's on GitHub. So right now, for example, I can show you the source code. You know, here's XA Wolfram mod.el, and you go to the source code. So there's about 2,600 lines of code, and you can go to this website, just search for it, show in browser, you'll see XA Wolfram mod, and it's on GitHub. So why do you code Wolfram language in Emacs? Because Emacs gives, you know, especially with soft-like keys, gives me much more efficient keystrokes to manipulate. So anyway, XA Wolfram mod, that's what I'm using, okay? So let's see, let's map, okay? So you map a function. So typically in most other languages, let me show you, okay? So let's say 1, 2, 3. Okay, so you can run it. Okay, so here's the result. This map function are familiar to you, most of you. It's available in Python, JavaScript these days. It wasn't, you know, over the past 30 years, programming language kind of improved a little bit. Functions like map doesn't exist 20 years ago. And gradually it's in kind of in Perl, in Python, then today in Rust, of course, you know, because map is kind of the functional programming concept, okay? But anyway, you are familiar with this. You map means apply the function to each element in the list. So you get that, okay? So copy that. We can do this in Wolfram language. So, okay. So what, so that is the map function most of us are familiar with. But here is the power of Wolfram language. Okay, so let me see. Let me go to yeah. So you can map a function to any specific depth of a tree. So let's say let me show an example. Okay. Okay, that's the output. Now let's see what are the questions. Hello, so glad you found your account. I just begun learning Lisp and have found your content incredibly helpful. Thank you. Hello, George. So there's a guy, I believe a Chinese guy, who bought my Emacs tutorial 2 days ago. I'm gonna send it out. Okay, so if you like my stuff, you can buy my Emacs tutorial. You can find it online. Just search for XA Emacs tutorial. So anyway, so this map function returns that. But what if you have a tree like that, for a nested list? Okay. Am I doing well? Yeah. Can you see it? Yeah. So yeah. Okay. So what if you have that? Okay. So let me show you. So here is our function. Wait. What happened? Paste it. Okay. So XX is a nested list, right? So you can also show it in kind of tree form. So actually, let me do this so you are familiar with. The percentage sign means the last input. I mean the last output. Okay, let's say XX. Okay, so tree form will show the nested list in kind of the tree style. So you can see that. Okay, so anyway, so you have a nested list. Now you want to map. Okay, so let's do it. So map. Okay, normally when you map, you get that. Okay, now let's map to, You see, you apply the function f to each of the element, right? Now, let's say I want to map to all the leaves of the tree. So what are the leaves of the tree? That means A, B, C, D, E. So you can compare over here. So how do you do this in Python? Well, it's very cumbersome. You cannot, okay? So in Wolfram language, you can, just like this, -1. Okay? So this argument, the third argument, specify the level, which level you want to map to. For example, a second level. In Unix, it's called depth. You know, in Unix, when you find some directory, you type the command find, you can specify a depth. But in Unix, that means if you specify 3, that means depth up to 3, 1, 2, 3, 1 and depth 1, depth 2, depth 3. But you cannot specify just depth 3, not 1 and 2. You cannot do that in Unix. But anyway, so here is how you map to to the leaves. So you can see. So let's see tree form. Okay, so let's show it in a graphical kind of way. So you see those A, B, C, D, E. Now they have an F in front of them because F is mapped to the leaf. Okay, that's the power of the Wolfram language. So why is this useful? Why is this useful? You know, because I write my HTML, so here you can see kind of, you know, my directory, not here. Okay, so let's go to talk show. Actually, so open that, put it back, color it, showing browser. So here's what we did, you know. So, but we go to the directory, shrink. So you can see this is my directory, go up one directory, shrink. So you can see this is my XARD info directory. So for example, you can go to Emacs, then you can open Emacs subdirectory, then you can open subdirectory. So that's a picture, you know, lots of pictures of Emacs stuff. So anyway, so you have nested directories. So sometimes I want to do a find and replace on all the files in a directory. But however, I only want to do them on level 2, for example, specifically, or subdirectories that are at the depth 2, not depth 1, just 2, not depth 3. So sometimes you want to do that. So in Unix, you know, typically the command is find dot depth, you know, and you pass it to what's the you xargs and set or grep whatever. But the depth, it will do depth 1, depth 2, depth 3, you know, all of them. So that's no good. I just want depth 3. You cannot do that. So that's one of the example. But why do you need to do that? Because when you have a file with lots of relative links like dot dot slash dot dot, you know, you want to specify the same level of directories. Otherwise, all your relative links will be screwed. For example, I want to change the name. For example, this is a CSS file. You know, this is a CSS file. So if I renamed the CSS file and I want to change all of the links to that file, you have to be sure that, you know, you kind of just, or I mean, if you moved this file to one directory up or one directory down, so in that case you want to change all the relative links. When you do that, you want to specify just the third level directory, such things like that. Okay, so anything else? So yeah, okay, so that's about this concept. Okay, so this is about, so the map function, you can specify a level, like what, or a range of level, like from the first one to the third one. And when the level number is negative, that means count from the leaf of the tree. So if you have -1, that's the leaf of the tree or the nested list. If you have -2, that's the that's one branch above the leaf. So this is very powerful. I've been programming Wolfram language since 1992. Then I started to learn Lisp because Lisp is very much related, and I don't see this in Lisp. So I was wondering, because I was a fan of Wolfram language and Lisp, because Emacs and AI. So how come Lisp doesn't have this? I was puzzled about this issue for 20 years, since about 2000, year 2000. So I talked to the Lispers, the master Lispers, the expert, the common Lispers. They don't they don't know. I mean, they don't buy my. They think who needs to do that? They don't get it. So 20 years ago, I'm not, I don't know, I'm kind of a beginner programmer, I don't know much about things. Then I try to tell them, Wolfram language, look at this, and they don't, oh, that's fun, that's it, So I was puzzled, and sometimes I got into heated argument, they don't get it. So they'll say, nobody does that. Or they'll say, oh, it's trivial. You can just write it in 5 minutes, which is false, by the way. Okay, I got an argument with Dion. So I was puzzled for 20 years. But over the 20 years, I have learned so much programming languages, computer science, algorithms, theoretical computer science. I kind of now know why Lisp does not have this. The reason Lisp does not have this, because the cons pair fucked it up. Because in Lisp, lists are not primitives. Lists are made of cons cells. Anyway, do I make sense? So if you want to know about that, so you can, I have written a lot articles about these cons issues. So you can read about fundamental problems of Lisp. This article, just search for it and read it. This is written in 2008. Okay, and the cons thing, the Lispers, why do they not agree or understand this point? And ultimately, that's because it has become a code, just like Emacs or Vim or Unix, Unix philosophy. When you become a code, people don't think anymore. Could we implement custom support inside of Lisp to support it? Yes, you can. So, it's a great exercise just to write this function, okay? So if you are learning Lisp, you could try to write a Lisp program that does this, okay? There are some libraries that kind of similar, but never comprehensive. Like what I'm doing, let me show you the documentation for the map, okay? So in XAR tab F, in XAR Wolfram mod, you can see the documentation for the map function, turn on JavaScript. And now enlarge it. Now you can see there it is, the level spec, okay? And then you see the level spec can be a number or it can be infinity. That means to all levels, whatsoever, 9,000 or a million. Or you can put inside a curly braces, that means specifically just that level. Otherwise, it's 1 to n. Okay, or you can have two numbers in a list. That means from this level to that level, a range of levels. So you can read this, and there's a lot of examples. Then you can try to implement that in Lisp. Okay, so you see the thing about this this thing Levelspec is that in general, when you have an expression, let's say this one, nested list, nested list is tremendously useful because nested list is also used to represent matrix or nested matrix or five-dimensional matrix or tree. Any tree is a nested list. Okay, so when you have a tree or a matrix of, let's say, 10 dimensions, the level spec or the level of the tree, which basically means you can specify a particular column or depth of the tree. So any function, not just the function map, any function that deal with list in Wolfram language has this level spec parameter. So this is just not for this function. So for example, you want to delete certain elements, you can specify only at that level, when they match your function or something, or when they match your pattern, or when they are 0, or simply delete everything in that level, things like that. So for example, I can delete all the leaves of the tree, so okay, so delete anyway, so that's about that. Yeah, Clojure is a different. Clojure doesn't have con cells, which is excellent. It's like finally after 30 years, Clojure is excellent. However, Clojure issue with Clojure is that it is heavily intertwined with Java. So I like Lisp very much. I've been coding Clojure for about a year, and get paid for it. Thanks to David Pollack, one of the big Clojure coder, well known. Okay, David Pollack. So he was helping me. He paid me to do some Clojure work. Clojure, the language, is a Lisp, right? I like it very much. However, I realized it's deeply intertwined with Java. Of course, it runs on JVM, but however, the language is not independent from Java. Like every notion, it refers you to Java objects, Java regular expression, Java string. This function creates a Java string. What does that mean? Well, you look up the Java string documentation or Java regular expression documentation. So it's deeply intertwined with Java. And Java is a circuits language and extremely complex because, if you don't know, it's, object oriented. You have to call object, you have to write classes, then create object, then you have methods. It's like pure OOP. So then you have, in Java, then you have abstract class, you have interfaces, so in Clojure, if you really want to understand it in depth, you read the documentation for Clojure functions, get the element of a list. Then it says, oh, this is the Java interface something. So you have to look up, you have to understand what Java interface means exactly. So that is the bad part about Clojure I don't like. Okay, anything else? So let me show you some articles I have about what we just talked about. So I have a lot of articles. So during the time 2014, I wrote some basic Clojure tutorial. Okay, and then the article I want to show you is, so in Clojure you can call every Java methods. Then you have collections, list vector, set map, and sequences. So Clojure doesn't have the Lisp cons. That's excellent. Yeah, but the problem is that it intertwines with Java so much so that you basically have to, if you really want to master Clojure, you have to kind of master Java too, because the Rich Hickey, he came from, Java enterprise programming. So where is it? So let me find the article. So there it is. So these two articles I want to show you. One is Clojure's popularity, a tango with Java. Okay. So I explain why it's intertwined with Java. So wait, is this one or another one? Trapped in the Java train, northbound is Clojure, southbound is Scala. Okay, people don't like Java. That's why so you have two choices. So the one I want to show is, okay, why Clojure is dense. Okay. So in this article, you can see how it is, what I think Clojure is fairly complex. It's like paradoxical, because the guy, Rich Hickey, his idea is he's very much emphasizing simplicity, which I completely agree. Programming language becomes so complex, and you have different protocols, you have different languages, and many details and exceptions, and especially in Unix, lots of problems. And all these problems essentially stem from complexity. For example, in JavaScript, huge number of watts, and DOM, it's like shit, total shit. So Rich Hickey, one of the things his idea, his philosophy in programming language is like focusing on two things. One is, he like pushing it, like the idea of simplicity. He thinks that is the most important thing. I totally agree. Now the other idea he pushes for is functional programming and parallel programming, which he created much of Clojure is that. Okay, so that's also a good thing, but I don't know much about that topic. Parallel, concurrency and parallel programming, these are kind of related but separate. So anyway, Clojure is very and functional programming. So no states. He has a philosophy about the whole thing. But anyway, the other thing he emphasizes is simplicity. He's got a jargon, something like I forgot what's the jargon. Something is simple to do. When you do something that's, I forgot what's the jargon. But anyway, simplicity is one of his emphasis. Okay, but however, the Clojure language is deeply intertwined with Java. So in that sense, there's no simplicity, because when you want to understand, for example, here, Clojure collections. So you have this different type of data structure: list, vector, set, map, and sequence. Okay. So normally when you want to master a programming language, you study the detail, and all these, these are the most important things in any language. Basically, list, hash table, or dictionary, or tuple, or vector. Because that's your data. That's the most important element in just about every language. So Clojure has them, list, vector, set, map, and sequence. Okay, so you want to understand the detail, what's their differences and so on. So when you study Clojure, then you'll see, let me see if I can show an example. Let's say Clojure vector. Okay, so this is very outdated Clojure documentation I have on my site. array map. Okay, so you have this array map key pair. Okay, so you have different, you have very fancy ones: array map, sorted map, hash map. Okay, let's look at array map. Okay, so I'm trying to find an example where they talk about so basically what I'm saying is that let's see Clojure map. Okay, Clojure map function returns a lazy sequence consisting of the results of applying F to a set of first items of each collection. Also, Clojure prefers to use all these abbreviations. Okay, so first item of each collection followed by applying F to second item in collection. So anyway, my point is that when you look into the detail, what are the collection and differences, they basically just say it's a Java interface for something. Okay, so then you have to understand what exactly is, is a Java interface and so on. So actually I have an example somewhere here. Okay, let me read it then. This stuff, parent, macros, reader. Okay, so that's all part of Clojure, very complex. These are the reasons why Clojure is hard to understand. It's kind of hard to learn language. So first of all, it has the Lisp concept of parent, macros, and reader. Now, reader is a thing very few people really understand. Okay, so Clojure has that. Then Clojure has its own idiosyncratic concept and technology that does not exist in any other language. Okay, not in Haskell, not in Erlang, not in Wolfram language, not in Common Lisp, not in Emacs Lisp, not in Java. Okay, it has like its own. You know, for example, transducer, metadata. That's what not that this Clojure metadata. That's not what you think when you think of metadata. It's kind of different. Okay, no other language has it. Clojure has its own concept of protocol. When you hear the protocol, you might be thinking HTTP protocol, email protocol. That's not what it is here. Clojure has its own protocol. Clojure has ref and transactions, atoms and agents. Those are related to concurrent computation or parallel computation. Okay, so this concept not in anywhere. Clojure, that's Clojure's thing. Then Clojure has this abuse of syntax and terse function names. Okay, for example, let me show you. Okay, so these are what's called sigils in programming. Okay, so basically weird characters in function names like that, or slash, or so here is a page that explains them all. Magic characters, or you call them sigils. That's part of the function name. So for example, you can have slash. Slash is for namespace separator. Okay, then you have the asterisk in function name or variable name in identifier name. That means when you see an asterisk, a name starting and ending in asterisk, that means this name is built-in. Okay, it's a built-in variable. Okay, then if it start with asterisk but not ending with it, that means it's built-in variable whose value will change often. Okay, so then you have question mark, then you have exclamation, you have you have minus sign, you have colon, you have double colon. So and you have then you have ampersand, you have percentage, so this kind of thing. And you have a dot, one single dot as a function name. Okay, then you have double dot, then you have dollar sign, some name dollar sign something. Okay, that means access Java inner class. Okay, then you have correct colon, correct quote, and you have @ sign, pound sign. These things, they break the convention of Lisp. Okay, in Lisp programming languages, typically they use full names. They don't use these cryptic shortcuts. There's a few in general, but in general, not Clojure is like got a ton of them. Plus, like then you have backtick, single quote, grave accent sign, then you have tilde sign, so Clojure is filled with this. Plus, their function names is very short, like they don't use full names. Often, for example, define, I forgot what's the define. Define in Clojure, define function is what, for example, function, okay? Yeah, fn, you see, fn. fn is defining a function. So Rich Hickey, he built Clojure. So it's filled with this, so you have def is one of the function to define a function. Fn is, I suppose fn is lambda, okay? I haven't used for a long time. So you have def, then you have defn, defn, then you have fn, cryptic names. That's all over Clojure, all over. So this is a departure from the tradition, the kind of the convention Lisp family languages. They don't have that. So Clojure is kind of unique in that sense. So anyway, so we are kind of digressing into why Clojure is dense, is kind of complex. Okay. So let's see if we can. Yeah, so you have that. Then you have abuse of syntax, terse function names. Okay. Then you have intermingle with Java, the language. Okay. So for example, sec. Okay, sec. Another very terse name, seq. Okay, that's a function name. So what does it mean? Usage. Okay, return a sec sequence. It means sequence. Okay, return a sec on the collection. If the collection is empty, return nil. Okay, return. Okay, and sec also works on strings, native Java arrays, and any object that implements iterable. There it is. You see. So you want to understand sec. One of the important questions. Then you read the documentation. Then it says, okay, native Java arrays. What the fuck is native Java array? What is the difference between, let's say, Java array and native Java array? You don't know because it's Java. It's talking about Java. Then it says any object that implements iterable. What the fuck is iterable? That's not a Clojure thing. That's Java thing. So you have to go study Java, iterable. Okay, iterable is an interface. So what's an interface? Well, you have to study Java interface, Java's concept of interface. Okay, then blah blah blah. Know that seqs. Okay, now here is a function seqs that's different from seq. So it says, I don't know if that's a function or what. So note that seqs, cache values, thus seq must not be used on any iterable whose iterator repeatedly returns the same mutable object. The fucking incomprehensible fuck. That is why Clojure is dense. In this document, just in this piece of documentation by itself, they mentioned one bunch of Java concepts. That's not part of Clojure. They mentioned a bunch of Java concepts, and the using of the extremely terse abbrev. You don't know what he's talking about. Then like the Rich Hickey guy, when he write documentation, it's like he assumed you've been programming Java for 10 years and you've been programming Lisp for 10 years. That's a situation, like a bunch of then is the sequence should not be used on any iterable whose iterator repeatedly returns the same mutable object. What the fuck is that? There it is. Now, this documentation I'm quoting is kind of old from this article 2016, okay? Now, let's look up what is the current article for the SEQ function for Clojure. Clojure SEQ, okay, let's see if we can find it, okay? Clojure sequences, okay, that's not a good documentation because this is one of the essay Rich Hickey wrote. You know, you can try to read this one. There are about 10 of them. Rich Hickey. So this article is kind of documentation, sort of, because it's an essay. It's not actually a documentation in a normal sense. It's like part of the 10 extra essays where he talks about, he kind of introduce you the ideas of Clojure things like data type and whatever. So, so there's an essay about sequences. Clojure defines many algorithms in terms of sequences, SEQs. A sec is a logical list, and unlike most lists where the list is represented by a concrete two-slot structure, cons, he doesn't mention, Clojure uses the ISEC interface. What the fuck is ISEC interface? That's part of Java again. So Clojure use the ISEC interface to allow many data structures to provide access to their elements or sequences. Okay. So anyway, so there is a link to the sequence function. So let's click on that. Okay, so here is the documentation for the current documentation for the SEQ function. Yeah, exactly, just like I quoted. It didn't change, one bunch of JavaScript jargons that you don't understand. Any tutorials on setting up Emacs for TypeScript? Yes. So how long have I been talking? Close to an hour. So maybe that's it. So I guess today we talked about Clojure and we didn't talk about machine learning much. Yeah, machine learning is very interesting. Let me answer that question, okay, TypeScript. And also let me mention some news about Richard Stallman. This is what he looks like today. Apparently, it seems like he got cancer. So it's kind of sad. Although it's kind of sad because after all he has been leader of the Emacs. Well, I mean, he made Emacs, right? Emacs is my favorite thing. I've been using for 20 years. So, and in the past 10 years, he has not done very many great things for Emacs. But still, he's one, the founder. So apparently he got cancer. I'm not 100% sure yet, 90%, because I just learned about this today. You can click to watch the video, so something, so he lost all his hair. So it's, he looks very different. So yeah, so about Clojure, yeah, Rich Hickey. So Clojure, I wish here's my last word about Clojure. Now, all these issues, there's one thing that is most problematic to me. That is the intertwining with Java. Okay, so if Clojure, because Java is the worst language. It's huge, humongous, and it's slow. Okay, it's some people claim Java is actually fast, very fast. Well, the practical matter is that whenever you develop in Java, you have to run JVM, including Clojure. And all your fans, if you don't have a fast machine with lots of memory, all your fans start to whore whenever you run a application written in JVM. And and Java is the sickest, worst language. Today is what it was created by Sun Microsystems, one of the most scum corporation back 20 years ago. Sun Microsystems, most scum corporation. They try to, not support Linux. Anyway, that's history. You guys don't know. And Richard Stallman has written about the Java trap. But anyway, it's very complex. You go to Oracle site, then Sun Microsystems, they love jargons. Java 1, JVM, Java Enterprise, JVJS something, Java Beans, 100 bunch of incomprehensible jargons, Java. And when you go to their website, then you have development, JDE, Java Development Kit. Then you have the Enterprise Kit. They have so many versions. Like, you don't know what the fuck is going on. Java, like the Sun Microsystems, they created Java. They are the worst, the marketing scum, and they do bad things. Okay, JavaScript, Sun Microsystems. Then it got bought by Oracle, another giant, biggest scum in the computing industry, Oracle. So then Clojure is like intertwined with it. Yeah. When you start the Clojure app, if you don't have 1,000 gigabyte of memory or stuff, or slow computer, all the fans start to whirl. And then every time you try to master Clojure, then you read one bunch of Java stuff. Like, oh, this is Java ITER interface. What the fuck is ITER? What is fuck is ITER interface? You're gonna go study Java interface, So that's the situation. I also coded Java for a year, long ago. So you could search for my Java tutorial. My Java tutorial is very old, okay? So it's like 15 years old, okay? So if you want to know about, like very solid fundamental concepts of Java, what's Java interface, what's abstract class. For example, you have abstract class, very complex, the OOP fuck, then you need abstract class, then you need interface, then you have arrays, then you cannot do, it's like, it's just shit, okay? Java, but better than C and C++, I would say. Okay, so yeah, the one thing I wish is that Clojure, of course, Clojure calls itself a hosted language, just like JavaScript, meaning that it's not a language independent. It's not an independent language like Python, Golang, Common Lisp, or Ruby, or Perl. But instead it's like it needs a host. Okay, so the current implementation is like hosted on JVM. So it kind of like, so that's what it, called hosted language. So you have in Clojure, you can access all Java things. So what I wish is that, so it's hosted, okay, but stop, at least in your documentation, stop constantly refer to the Java stuff. Try to be, independent. Then, and, my best wish is that Clojure becomes an independent language, so you don't have to run on Java JVM. If that is the case, if Clojure becomes independent, I would love it. A modern Lisp. I don't want Java. I don't want anything to do with Java or JVM. Okay, the question about TypeScript is that well, for me, okay, so let me start the TypeScript, okay? So right now you are seeing my talk show, and let's start a TypeScript. I'm using XHTML mod, and so you can see I start a TypeScript block and show in browser. There's empty TypeScript. Then I press a button, it pops into its own window. Then let's say console log 3, let's say constant, okay? In TypeScript, you can define types, right? I haven't been doing TypeScript for a long time, so I suppose, you know, it's actually redundant because it can infer. So here's a TypeScript, and let's say console log x, okay? Print it, and let's say, so I have my commands. So I'm using, actually what I'm using is XAR JavaScript mod. Okay, so let me show you. Actually, I can just go here. So I have a command, XAR TypeScript compile file. Okay, eval region, eval line, complete symbol. I can run this script, for example. Let's run it, okay? Oh, string. What is the, it's been a while. I type, let's see. Let's see my TypeScript tutorial, which is not very good. It's just basics. What is the, oh yeah, you forgot the colon. Okay, so you have to put a colon there. Okay, so now if you run the script, you can see it's TT. Okay, let's say something. Okay, run it. Okay, that's the output. And the command you run it is XAR run current file. Okay, so you can search it. Okay, so you have the code in Emac Lisp. You can copy it and you'll get it. You know, so you can do the same thing I do. But if you want to run TypeScript, you need to install Deno. I highly recommend Deno. Okay, so let me show you the page. Deno intro. It's the best. Okay, never use Node.js or npm. Use Deno. Okay, there's a new one called Bun.js. I don't know too much about that one, but I highly recommend Deno because the guy is a great guy. He's one of the most competent programmer and mathematician, and also most integral. Ryan Dahl. Okay, he created Node.js, but Node.js got corrupted with, you know, that guy. What's his name? npm guy. A very bad guy. So I recommend Deno. So you have to install Deno, then you install what is this run current file. Okay, so where is that? Oh yeah, so you install, then you get the code here, install Deno, then you can run it. You know, just like what I'm doing, it just print. Then, okay, so that's one thing that will help you run TypeScript. The other thing is I'm actually using my own JavaScript mod. So let me show you. Okay, so you can see I'm using XAR.js mod. Okay, so open that. It's 1600 lines of code. If you like my stuff, you have to pay me. Okay, pay me and you get this file. So this XAR JavaScript mod, it also TypeScript, it also handles TypeScript. So for example, you have TypeScript compile file. For example, we go to this line, you have the TypeScript compiler, which compiler you want to use. I'm using Microsoft's default. Okay, so for example, let's compile this file. Close, close, close. Okay, so let's go to the directory. So here is the directory for that file. Let's delete the backup. Okay, so here is the file, TypeScript, and let's compile it. Okay, so tab C, now it's compiled, successful. Okay, so you go to the directory again, refresh, you'll see, too big. There it is. You see this and this, you see. So it's you see. So you open the, so this is a compiled output. You see, it removed that. Let me show you. Okay, it removed that string type specification. So that's one way to go. You can just use my, if you want, pay me. I think $30. Okay, it's open source. So otherwise I don't have much recommendation. I mean, Microsoft has one. Microsoft has a, let's search Xali TypeScript Emacs. Okay, so the compile TypeScript command is also here, so you can grab the code, just search for it. Xali Emacs compile TypeScript file, okay? And then I'm trying to find an article where they Xali Microsoft TypeScript. When TypeScript came out 10 years ago, they actually thanks me for my Emacs tutorial. So yeah, here is Microsoft original TypeScript package, TypeScript.el, and they thanks me for it somewhere. Let me go to my blog and find it. So there's a lot of articles about Microsoft because lots of controversies with Microsoft. Yeah, one bunch of Microsoft mouse and keyboard articles. Okay, so let's type Microsoft and TypeScript. Yeah. Some interesting articles. And this is back then when CoffeeScript is still around, and Dot, which is Google's trying to replace JavaScript, kind of failed. Yeah, this one is interesting because this is the source code of TypeScript. You'll actually find this in TypeScript source code. And that, you look at that. Okay, so yeah, I cannot find, wait. I want to find that article. So I think the title contains TypeScript, or it contains Microsoft. Microsoft minus keyboard minus mouse minus hatred. Thank you, Ben. There it is. Microsoft cites Emacs. So this is 2012 when TypeScript came out. So I think they, mentioned my Emacs tutorial for the Emacs package. Let's see if they're still there. Yeah, it's gone. Okay, that's it for today. I think Kaji search. I don't know what is Kaji search. Kaji used to be one of the like payment system. Like if you are an independent software developer, you can write your software, you can sell it on Kaji. That's what it used to be. But so I don't know what you mean by Kaji search. Okay, I think that's it for today. Anything else? Do I play any video games? Yeah, I used to, but now I'm getting old. Okay, thank you guys. Bye. Hello, Alan. You know, the funny things in our Discord, Kim Possum posted a video. Kasa's Hitler. Oh my God, Google is gonna censor me. I mean, I'm not going to show it. Well, anyway, bye. Okay, close, shut down in 1 minute. Now I want to gather all the links I've talked about and put it in the talk show page. Okay, so run current file, close, TypeScript compile current file. Okay, put it there, close that, and the Microsoft TypeScript miscellaneous notes. No, that's not it. Study search, TypeScript ladder flow. Interesting. Close. TypeScript will kill CoffeeScript and dot. Okay, that's kind of back then, 2012, when they are trying to compete. TypeScript misnotes. Close. Microsoft cites Ergo Emacs. Thank you. I need to change that name to Microsoft. Well. Okay, close. Bye.